Good afternoon, Dolaputala. Another beautiful day and really successful day that we are doing equilibrium. So maybe you guys would feel it's a little frustrating because each week I'm just doing two lessons to you. But I don't want to rush you during the last couple of months. That's why I'm doing this, just to avoid all the frustrations from your brain and then feel you like relaxed and happy, and then whatever you do, you can memorize very easily. And once you're done with equilibrium, then we're going to do unit 13 as well, but that's again a very simple, very small unit. Then straight, I'm going to start full papers and see. We were always talking about that everything. Finally, we almost done everything. We are going through the path, having this successness. Okay, we finish up to question number 82 from Ratnapura, and today I'm going to start from question number 83. 84. Which of the following statements is true? The solubility of stannous hydroxide in water is less than that in aqueous sodium hydroxide. The zinc hydroxide in water is less than that in aqueous potassium hydroxide. Both are amphoteric. Both reacts with strong bases to make oxoanions and plus water. So less water soluble, but when you are adding bases, these are more water soluble. Other two are the other way around. The solubility of calcium hydroxide and ferric hydroxide in water is supposed to be high than KOH and NaOH, because calcium hydroxide and ferric hydroxides are precipitations. When you add OH minus as the common ion, they increase precipitation height. Question number 84, A, B correct, answer 1. Okay. So potassium chromate, good oxidizing agent. Zinc, copper, ferric, and nickel belong to different groups in group analysis. Let's see what kind of questions they are asking. Which of the above is likely to give a precipitate with dill HCl saturated with H2S? Dill HCl H2S mean the acidic H2S. So that's group 2. And also these strong oxidizing agents can convert sulfides to sulfur as well. So that's what happened in these three. They were not, copper is also, see, this is oxidizing agent, and this is also acting as oxidizing agent A and C. So they convert S2 minus into sulfur. That's one condition. Then the second condition is a copper group 2 acidic H2S, since it needs less sulfide concentration, it is precipitating black color copper sulfide. Zinc group 4, nickel group 4 need basic medium or more sulfides. Question number 85. Answer 4. Suji? Suji? Enna? cool water. Wash කරවත් නැහැ නේද මේ රතිපු ගමන් නේද? Wash කරලා cool water එකකින්. Finish. Okay, moving to question number 86. Which of the above is likely to liberate I2 with Ki? Ki I minus, I2 0. So that's supposed to be oxidation. So again, we are going with oxidizing agents. Then we have chromate and ferric that converts I minus to I2. See how they're getting the knowledge. And also this copper oxidation number here is +2. That has the ability to convert it to I2. All these reactions I've given you to write. This is with the +2 lowers, and this is with the +2. So they cannot get oxidized. They cannot act as oxidizing agents. Question number 86 again, answer 2. Okay, moving to question number 87. Manoj, can I move? Which of the above will oxidize acetic? That's again good oxidizing agents. Under certain specific conditions, with strong oxidizing agents, it's converting to acetaldehyde going to acetic acid. So that's acidic potassium permanganate. And we have this copper 2 plus reaction that is the failing reaction, that it is converting to acetate plus this Cu2O red brown precipitate. 87 answer 3. Good. We're correct. Tell me. Wow, well done. Question number 88, again, still under group analysis. The inorganic compound D, when treated with dill H2SO4. With dill H2SO4, I gave a brown gas and a colored solution. Nitrite, no reaction with dill condition. Nitrate, I mean, nitrite NO2. Which is a brown color. This is nitrite, again brown color. Nitrate, no reaction, nitrite again, brown color NO2. Solution has then Cu2 plus, cadmium 2 plus, nickel 2 plus, they have colors. When an excess ammonia was added, blue solution. Tetraamine copper blue. Cadmium, what do you know about this cadmium? Cadmium is in zinc group. So we're going to think about same as zinc. Zinc, cadmium, mercury. Zinc, cadmium, mercury. Then nickel, hexaamine, that's again blue. So now we can narrow down the answer to 2 or 5. Next one, H2S is passed into another portion of organic colored solution. Black precipitate was not obtained. Gonna go with D. This is giving the black precipitate. So the medium is acidic. Since the medium is acidic, no precipitate for group 4 nickel sulfide. They say a black precipitate was not obtained. So 88, answer 5. '89, copper sulfide dissolves in hot till HNO3. All sulfides dissolve in acids. In the presence of hot till HNO3, the Ksp of copper sulfide increases. Ksp depends on temperature. When temperature increases, ionization increases, Ksp increases gradually. Copper sulfide dissolved with this reaction between nitric and copper sulfide. It is producing this H2S acid, H2S gas as well. So this is dissolving not with Ksp something, but it goes with a reaction. Since there is this reaction, we cannot say only increasing or decreasing Ksp, this is dissolving. So 89 answer. Question number 90. When saturated aqueous solution of AS2S3, arsenic sulfide, 2x, 3x, what is the following pertaining to the system true? If the dissolution is x, then here 2x to the power 2, 3x to the power 3. So answer become 5. Then what is the answer? Manoj, what is the answer? Why? Yeah, because see, sometimes this question is trickier. Sometimes they were given units, sometimes they were not given units. So both supposed to be inclusive. Let's say that all didn't have units, then we have to go with that unitless answer. But there are two different varieties they were asking. 1999 question. Question number 91. When ammonium chloride and ammonium hydroxide are added to an aqueous solution containing magnesium 2+ ions, no precipitation is obtained. When only ammonium hydroxide is in the medium, you have more OH minus in the medium. NH4 plus is common ion. NH4 plus from this first equation, equation number 1, controls the equation number 2. When NH4 plus is increasing, this reaction, second reaction, shifting to backwards to decrease NH4 plus, at the same time it is decreasing hydroxide. Therefore, hydroxide concentration is not enough to precipitate magnesium as magnesium hydroxide. Therefore, in ammonium chloride, ammonium hydroxide medium, magnesium hydroxide does not get precipitated. This is the explanation for structured assay and assay. First statement correct. Magnesium hydroxide is insoluble in ammonium hydroxide. It's not soluble, insoluble. To get dissolved in excess reagent, it must make a coordinate complexes. This is not making coordinate complexes. So that it's wrong. Question number 91, answer 3. Manav, if she's writing, it simply mean you are just wasting time. You can write the same thing because this is directly the answer and keywords and everything for such questions. Okay. And now we are moving to question number 92. Cation will give a blue solution with excess ammonium hydroxide. For first one, only nickel and copper gives blue coloration. No precipitate with H2S, so that's acidic H plus. Acidic H plus group 2, Cr3 plus group 3, nickel group 4, cobalt group 4, manganese group 4, not precipitating. This is a yes precipitation. So that nickel is again no precipitation. Yellow brown with conch HCl. So these are the colors I've given. So that's again nickel. So 92 answer. Did you guys hear a ring? Maybe sorry. She has forgotten. What is the time I posted? 2. Okay. Question number 93. A dill HCl solution is dill HCl solution of a salt A is colorless. Can be any of these. Orange precipitate, white precipitate when added to water. That is the key point. This is my second point, and this is my first hint. Either antimony chloride or bismuth chloride, both antimony chloride, bismuth chloride given, orange precipitate with H2S. Hi, Dad. Come, darling. That's acidic H2S group 2. That's supposed to be antimony sulfide, the orange precipitation. So then question number 93, answer 2. Question number 94. 94. MX and NX2 showing these two solubility products. M is univalent, N is divalent. They want to go with these comparison, but before that, let's do the calculation to find this connection. Okay, if MX is P, then this is P and P. If the solubility of NX2 is Q, This is Q and this is 2, so that this is become 2Q. So if you analyze this and write these KSP equations and substitute this solubilities or concentration of M plus X minus N2 plus 2X minus, then you end up with P equals to 1 into 10 power minus 4, Q equals to 1 into 10 power minus 4. Then if you go with these 4 ions, all these M plus, X minus, and N2 plus is 1 into 10 minus 4. But since this is 2F, 2Q, this is become 2 into 10 power minus 4. So that question number 94, only AD correct. AD correct. I lost the annotation. This is the explanation. Okay. English one, again, I guess I have it. Yeah, anyway. That's question number 94. A nickel solution of DLHCl does not give a black precipitate. With nickel sulfide, precipitation of nickel sulfide with H2S. Nickel need basic medium because high sulfide concentration needed. Group 4 need high KSP, but with HCl mean acidic medium, only group 2 getting precipitate which needs low KSP. Nickel sulfide is easily soluble in DHCl. This is inorganic knowledge. Insoluble in cold DHCl and in acetic acid. Soluble in conch nitric and in aqua regia, which is 3HCl2 HNO3. Question number 95, answer 3. Can we correct? Sorry, correct? Done. This last week, we have a couple of these very fun students from Royal. That your friends, brother and all. Then we were talking about on Naduala, Sinhala medium. Naduala, ලෙලකින්වත් අපුරට මේ විදිහට කරනද ඒගොල්ලන්ට මේ විදිහට කරනවද they would think that other persons can understand things seriously. Okay. Question number 96. A sample of water is contaminated with ions of metals. Adding sodium hydroxide solution to water sample gives a light green gelatinous precipitate, nickel green, copper pale blue, mercury yellow, mercurous oxide. Okay, mercuric oxide. Don't worry too much about 4 things that we didn't do. This is from oral question. Chromium green and stannous white gelatinous. So we can stick to these green answers, which forms a dark blue addition of ammonia. This is blue and this is blue, this is yellow. So narrowing down to 2 answers. On passing H2S, acidic H2S, no precipitation. So this is yes precipitation, black. And this is the no precipitation because you need group 4 condition, high concentration of sulfide. See how easy these questions are, exactly same principles they are continuously asking. Question number 96, answer 1. Question number 97. Which of the following tests can be used to distinguish between aqueous solutions of nickel and copper? Okay. Addition of excess ammonium hydroxide. See, nickel and copper both give same blue solutions. ConCl, both are yellow. SO2 cannot reduce nickel 2 plus, but copper 2 plus can be reduced to copper plus. So the color blue become colorless. Concatenation for heated, this sort of a reaction is also possible. Metal converted to copper 2 plus, but consider the given condition. Passing H2S after addition of excess ammonium chloride. It simply means the basic condition mean you have more sulfide, less sulfide needed for copper, it is precipitating. More sulfide needed for nickel, so that it has enough sulfides to precipitate both. Since sulfide concentration is high, both give precipitates. Silver nitrate, white, silver chloride, and silver sulfate precipitate. Question number 97, answer 3. Manoj, when you do this, you refresh these colors, precipitation, all these reactions from inorganic chemistry. Dhoni? Sudu? Memorizing everything, refreshing everything. Okay. You guys don't feel like mathematics and so is it something there? If you feel like you have forgotten, that's a red light. You need a full cycle. So how are you going to do that? So starting from S, starting from P, starting from D, same day, same time. Let's say this is the first hour, second hour, third hour. Okay. Now we are not going one by one. Okay. Question number 97, answer 3. The solubility product of the ionic hydroxide MOH twice is given. Hydroxide concentration is asking. So dissociation X and 2X. Then KSV become 4X to the power 3. Then do the substitution. Then X equals 5 into 10 to the power minus 4. But OH minus is 2X. So multiply that by 2. 98, answer 2. The solubility of lead fluoride in ConCl is high because it is making this complex. Then the solubility in cold water, it is not low, so it is wrong. The presence of common ion generally changes, yeah, either increasing, either decreasing. If precipitation is forming, solubility decreasing. If complex is forming, solubility increasing. That's a summary. 99, answer 4. Anyway, right after the exam, 24 exam this year, I'm going to ask you to make this. It's a must. But you can say, I need a summarization of unit 12. Could you do that? Right after exam. Otherwise, you forget things. That's for me, not for you. Can you do that? As a support. Come on. I never say I try to manage. Doesn't matter. Sorry, are you making short notes? You get that. Short note means important stuff. Now you know the short note of organic animal. Yeah, I know. That's from the beginning. When you're writing at the beginning, you would do that. But with practice, you won't do that. Can we move on to 100th question? Question number 100. In group 3 of qualitative analysis, quality, the filtration from group 2 boiled to remove H2S. This avoid reduction by H2S and formation of sulfur. This makes the medium turbid, which makes a medium turbid. So to avoid that boil part, then heat with nitric to convert Fe2 plus into Fe3 plus. Since KSV of Fe2 plus is high, it's difficult to precipitate all Fe2 plus. Then adding ammonium chloride and ammonium hydroxide. Ammonium hydroxide gives the basic medium that we need to precipitate as hydroxide, but adding ammonium chloride to reduce hydroxide of the medium. So that is the, again, explanation for structured essay question, but there we have to show it equations as well. 100 questions of equilibrium is a victory. You don't do, I guess, even closer to 100 if you are not doing classified. Altogether will be 100, like structured essay and everything. Question number 101. Which of the following columns? Correct observations. Answer 5, everybody? Tell me. Well done. Okay, you guys are not copying from any other resources, I guess. Are you copying anyway? Tell me, be alert. You look like, I like a drunken person. You look like. I would be, sorry, I forgot class is at 2:15. I was having a nap and I heard your bell ringing. And I just jumped out of the bed and came here. Okay, so see, silver nitrate with dil HCl, silver chloride white precipitate, silver sulfide black. So it's not white, not correct. No precipitation, yeah. Barium sulfide is again aqueous. They say they are supposed to be white precipitate, so that's again wrong. Cadmium chloride is aqueous, so no precipitation, that's true. Cadmium sulfide is black, sorry, yellow. They said it's supposed to be black, so that's again wrong. Magnesium chloride is aqueous. Magnesium sulfide is again aqueous, no precipitation, that's correct, but this is incorrect, so this is again wrong. Chlorine, no precipitation, yeah. Fe3 plus with H2S reduce into Fe2 plus, at the same time they are making this sulfur. So that's correct, both correct. So the correct answer is 5. Question number 101, answer 5. Anybody, do you want to write? Question number 102. This cation a cation that formed hydroxide which readily reacts with oxygen under basic conditions. Readily react, let's see who we can go with. Chromium with oxygen, atmospheric O2, there is no such reaction. Chromium, this is the identification test. It is converted into yellow color chromium with oxidizing by H2O2. This is the highest oxidation number, no more oxidation. Cobalt hydroxide can be oxidized with atmospheric O2 to this CO3 plus brown black. That's possible, but that we never talk about. It's really a fast reaction. We never talked about that, but this is really faster. In the presence of sunlight, this is converting very easily to MnO2. And that we did this reaction for Winkler method under unit 14. Fe3 plus, it's supposed to be Fe2 plus to Fe3 plus, but given is Fe3 plus. See, I've given all these examples to one single place so that your lives of inorganic became easier. Now equilibrium easier with the same short note. Anyway, question number 102, answer 4. Question number 103. No chloride is more soluble in conceptual than in water. Okay, lead chloride is more soluble in HCl than in water, making this complex. So no chloride means wrong. When formation of coordinate complexes, solubility in HCl increases due to the common ion effect exerted by the large Cl minus ion concentration. In concave Cl, the solubility of all chloride decreases. Only when making precipitates, they are decreasing. So they are talking about this all chlorides. That's wrong. Question number 103, answer 5. Question number 104. This one again, very simple calculation. See, KSP value is given. So here, if this is X, if this is Y, and if this is Z, KSP equals to X squared, 4Y to the power 3, 108 Z to the power 5. If you subject X, Y, and Z, Z is the largest, 10 to the power minus 14, and X is the smallest, minus 22 is the smallest. Question number 104, answer 5. Question number 105. 25 cubic centimeter solution of 1 m barium chloride, CV. 50 of 0.05 m sodium carbonate, CV given. Barium 2 plus ion concentration is asking. You have to memorize that barium carbonate is partially soluble. C. It's not necessary to go with that CV because that barium carbonate is partially soluble. But the given barium chloride CV 2.5 into 10⁻³ sodium carbonate CV 2.5 into 10⁻³. Stoichiometric ratio is 1:1:1. So that same 2.5 into 10⁻³. Okay. Then concentration equals that number of moles divided by 25 plus 50, 75. 75. That is 3.3 into 10⁻². I'm going to keep that in my mind in a side, but formed barium chloride is partially soluble. This is a precipitation. Therefore, cannot find barium carbonate concentration by above method. Even 3.3 into 10⁻³ can be seen in the medium. Only dissociated amount comes to the liquid phase. So you have a solid here. If let's say 3.3 into 10⁻², but from that solubility is X, then X of barium 2 plus and X of CO3 2 minus. They are asking barium 2 plus concentration. So both same. So I'm going to substitute here 1:1, so X squared. X equals 9 into 10⁻⁵, which is smaller than this, which is smaller than this. So we can accept this. Otherwise, we cannot get this answer as well. So if this is fully soluble, answer is 1. Since 1 is larger and this 4 is smaller, we can go with 4. But if this value is larger than this one, we cannot get this answer as well. Clear that? Okay. Question number 105, answer 4. (106) An aqueous solution of Sinhala plus. An aqueous solution of Sinhala plus and zinc 2 plus can be distinguished with ammonium hydroxide dissolving. Silver hydroxide unstable, so it is automatically converting to silver oxide spontaneously. So that this is brown, this is white gelatinous. From that we can separate. But if you add excess, then both become colorless. But this is the point we are separating. Can be distinguished, yeah. Both Sinhala plus and zinc 2 plus form precipitates with ammonium hydroxide, which dissolves in excess reagent. Both make precipitate. If can be distinguished by color, but separation is not going with, since they are making precipitates and those colors, but this is some sort of a reaction is also there. So that's so that we can separate these two with that. Question number 106. Who could answer two? Two. Let me read this part again. Both make precipitates. Can be distinguished by color. That's one. Dissolved in excess reagent 2 is correct, but separate by colors of precipitates. Both make precipitates. Yeah. In second statement, they were not talking about precipitates. Understood? Sorry, precipitate colors. That's why answer is 2. They're supposed to talk about the colors of precipitates. Question number 109. The solubility of any sulfide, see this is all one. This is pH 2007. This pH is wrong. For new nomenclature after 2019 is only F. Decreases when the medium is acidic. When the medium is acidic, H plus is high. So shifting to backward or left to decrease sulfides, so that to increase sulfide, solubility is increasing. So reaction is going forward to increase this. So that's supposed to be increased. Sulfide and concentration in aqueous decreases in acidification. That's true. That's true. Since equilibrium point shifting towards left. Towards left. That's true. 107 answer 4. (108). The salt acts in DiHCl, forming a colorless solution. Gives a white precipitate when dilution. Dilution white, we have all those two. Those are now like old stories. Antimony and bismuth chlorides. They were given both antimony and bismuth. Then we had to distinguish these two. Black precipitate when H2S is passed. Group 2, that's supposed to be bismuth sulfide. See this precipitation, then these colors I'm showing. Antimony group 2 orange. Question number 108, answer 2. (109). Which of the following true in the relationship of addition of some amount of calcium chloride to a saturated aqueous solution of calcium hydroxide? Calcium hydroxide saturated, adding calcium chloride onto that. Okay, refreshing your knowledge. But we still have 2 more books to go, or 1 book. Are we done with refreshment? Anyway, so only finished 2 books. Okay. When dissolving a compound, which is sparing soluble in water, in a certain moment, it starts to make a precipitate. Compound cannot be dissolved anymore once it's saturated in saturated condition, so that it is showing this equilibrium, so that we can write KSP. And there are 3 different kinds of solutions. Unsaturated mean not similar but less. So the iron amount is not enough to make the saturated solutions. Saturated mean iron concentration enough KSP, but even if you add a little amount of ion, it is precipitating. Supersaturation mean iron concentration is already high, so that excess iron concentration is getting precipitated to give 2 distinct phases. Okay. The given question since saturated, when addition of calcium chloride, calcium 2 plus is increases, calcium 2 plus, because of calcium 2 plus, it increases calcium 2 plus aqueous. So the reaction is shifting to backward or left to increase calcium hydroxide precipitation. So make more precipitation. Therefore, hydroxides decreases. Hydroxide decreases. So OH minus concentration does not change. Wrong. Some amount of calcium hydroxide is precipitated. With calcium 2 plus, hydroxide is also shifting to backward. Can you be clear? Understood? You are adding calcium 2 plus. So it is increasing. To decrease that, reaction going backward. So that precipitation increases. At the same time, OH minus is decreasing. So the first one they say hydroxide does not change. Wrong. Some amount of calcium hydroxide is precipitated. Yes. Third one is this calcium 2 plus concentration will increase. See, calcium chloride also has calcium 2 plus, which we are adding externally. So that definitely is supposed to be increasing. Whenever we are adding something externally, concentration is increasing. So that C is correct. H plus does not change. Considering temperature is constant, since the medium is aqueous medium, we are talking about the aqueous medium, OH minus concentration changes mean H plus concentration also supposed to be changed because this is the equilibrium. Clear that. OH minus changing mean H plus also supposed to be changed. D is so that incorrect. Question number 109. B is the correct answer. 2. Do you want to get this knowledge from the beginning or? Yes? I've forgotten. I'll stop. Can I move up here? Moving on. Question number 110. Which of following statement is true regarding ammonium hydroxide and zinc hydroxide? Soluble in excess aqueous ammonium hydroxide, only zinc getting soluble, but aluminum is insoluble in ammonium hydroxide. Insoluble in excess ammonium hydroxide, that's only aluminum hydroxide, because it's not making the coordinate complex. Precipitated by adding ammonium chloride, ammonium hydroxide to the solution, because since you have both these, now the concentration of hydroxide is less. So only group 3 is stuck. That is the only aluminum. Both are amphoteric, that we know from the ancient time. That's the correct one then. Both in aqueous medium, free aluminum 3 plus ion can exist as this way as well. But in aqueous medium, this is also possible. And when you add more and more water, solution makes more and more acidic, but it is not matching to any of this. Question number 110. D only correct answer, 5. Zinc 2 plus and manganese 2 plus are not precipitated as sulfides when H2S is passed in solution with acidic. Yeah, zinc and manganese, group 4, basic H2S. So that is correct. Okay, acidic H2S mean group 2. So if this is a reaction, when you add more H plus, to decrease that, reaction is going to backward, but it brings sulfides together, so that sulfide concentration is decreasing. Soluble in dill HCl, zinc chloride, magnesium chloride, even here is correct. But when you pass more, they are making complexes, that's also correct. Since so even in dill, this can be the situation, but still both soluble. Both statements correct. This is the explanation. Explanation is here. Explanation is not given. So answer 2. Question number 112. Solubility product of Hg2Cl2 is given. Concentration of Hg2 2 plus ion in a 0.04 sodium chloride. Okay. Sodium chloride 0.04 has 0.04 Cl minus. Let's say the solubility of mercurous chloride is X, then X and 2X. But now totally in the medium you have 2X plus 0.04. And 0.04 is higher. So since this 2x is very small, we can neglect. So that totally equals 0.04. Let's write the KSP of mercurous chloride. Okay, I'll write again if you need that. So that that become x into 0.04 to the power 2. So that we calculate x separately, and x equals to this 112, answer 3. 0.0016x. Down the other part that you don't see, 0.0016x, which equals 1.6 into 10 power minus 3x. Okay, calculation. Calculation. We are moving to calculation side now. Question number 113. Aqueous saturated solution of MOH twice. pH given. Solubility product is asking. pH plus pOH equals to 14. So pOH, I'm going to go with pOH because this is hydroxide. That equals to 4. So that pOH equals minus log 10 OH minus divide 1 moles per cubic decimeter. So that OH minus concentration equals 1 into 10 power minus 4 moles per cubic decimeter. So that is 2x. If you write this dissociation, if solubility is x and 2x, now 2x equals this OH minus concentration 1 into 10 power minus 4. Then x is supposed to be half of that. Then I'm writing KSP expression, x and 2x to the power 2. So that question number 113, answer 3. Always simplest questions guiding you to harder questions, same as in organic. Is organic tutorial a challenge? Have you feel like it has challenges? Very less, I guess. Isn't it, Sari? Or was it a little harder? Harder? No. Yeah. That's what happens if you go like really nicely. Whatever the question they are giving, you feel like, oh, I know the answer. For now, equilibrium is sort of same, I guess. Question number 114. Following cation analysis, during cation analysis, group 1 metal ions are precipitated as chlorides. Which of the following statement is true regarding group 1? Mercury, silver correct, mercurous correct, lead 2 plus correct, mercuric under group 2 wrong. Only silver chloride and lead chloride dissolved in the aqueous ammonia, and silver chloride, lead chloride, gives this silver amine, lead hydroxide when you add dill HCl, and lead chloride also this complex actually, okay? You can write that as well. Sorry, amine complex. Then addition of HCl, initially white precipitates with Kong, both gives these chloride complexes. Will not precipitate with the addition of dill HCl. No, with the addition of dill HCl, they both give precipitations. So that's wrong. That's why I have put this asterisk here. Okay. These three is correct. Lead 2 plus does not precipitate in hot conc HCl. Lead chloride dissolving solution, cooling reprecipitate white natives. Okay. So on the CD correct, 114 answer 3. This actually, again, if you're writing, you can write here this complex as well, okay? Both initially converts to hydroxides with ammonia, ammonium hydroxide, then complex and so on, you can write. Question number 115. xy3 dissociate to x3 minus and 3y, x3 plus and 3y minus. Solubility product is given. So a and 3a. So we are just writing a here, 3a to the power 3. So that equals 27 to the power 4. Then a become 2e to the power minus 3. But y means 3a. So 3 times of that. So 115 answer 2. Good. 116. C. All those questions, older questions. But in 2014, they're asking the same. So this reaction and this reaction solubility product of this reaction given, K1 and K2 given. So get this third equation using first and second. If you subtract second one from first one, you can go to third one. Subtraction mean division of equilibrium constants. So K1 divided by K2 is KSP. Just go through the calculation. 116, answer 2. Copy this down if you want to go back. This is again extremely simple. See, these questions are harder. I don't know how these questions are harder to what? Sai, what do you think? To who these questions would be harder? To who? Somebody who's not even turning pages. Otherwise, these questions are for students like who's going to get S pass, I guess. So this is 3 ions, 2 ions, 3s, 2s. So that you end up with 108 s to the power 5. Just memorize this. When you go on, you'd find that's easier. Like x and x, then x squared, then x and 2x, 4x to the power 3, and so on. Just memorize. Then this life going to be easy. Anyway, they're asking s. So subject then this s. Question number 117, answer 4. 118, see again, a little knowledge is expecting. BaF2 solid has higher solubility in an aqueous acid medium in water. Okay. Water solubility of fluorides decreases down group 2. Barium fluoride is supposed to be sparingly soluble. Even if you don't have that knowledge, they say, okay, you can get some sort of idea from this second sentence. BaF2 solid has a higher solubility in an aqueous acidic medium than in water. I'm going to suspend there. The second statement, when BaF2 solid is dissolved in an acid, due to the formation of HF, barium 2 plus concentration increases in order to maintain KSP. See, BaF2 solid, it gives F minus. Water dissociates this way, but this F minus with this H plus, they are making HF, which is a weak acid. So this dissociation is weaker, gives a less amount of H plus back to the medium, so that H plus concentration, sorry, F minus back to the medium. So now F minus is less. At the same time, H plus concentration is hang on. Oh, F minus is less and H plus concentration is also less. That F minus is reacting with this H plus to decrease. Which part is confusing? To decrease H plus concentration. Third reaction shifting to right to decrease H plus concentration. F minus is decreasing to increase, one shifting right. Okay, not 2. This 2 is not there, that's what wrong. So that H plus concentration is decreasing. So this third reaction is moving to, when H plus is decreasing, it decreases with F minus as well. So to increase that, this reaction is going to forward. So that barium 2 plus concentration is also increasing. Is that clear? Let me give a little explanation again. So barium 2 plus F minus, that F minus gets away with this H plus to make HF. So that F minus is decreasing. To increase that, this reaction is going forward. So that barium 2 plus is also increasing. Hear that? So that it maintains KFSP that way. BF2 has a higher solubility in N, so that solubility is increasing with that phenomenon. Clear that? So that answer equals to 1. Hang on, we have to write something little here. That's why this is unclear. Just write here, upon addition of acid, H plus increases. To decrease H plus, reaction is going to right. Question number 119. For saturated solutions of silver acetate, is contact with solid silver acetate, aqueous and solid. So solid silver acetate is dissociating into acetate and silver plus. With the H plus of the medium, it can make acetic as well. How does the solubility of silver acetate changes when the flowing are adding? When you're adding sodium acetate, we're adding this. So this reaction is moving to backward. So that solubility is decreasing. So 1 is incorrect. Dil HNO3, addition of H plus, more and more H plus adding. To decrease that, this reaction is going to forward. It is decreasing this one. To increase that, this reaction is also going forward. Clear? So it is increasing solubility, increasing. Okay. Ammonium hydroxide, silver plus with ammonia, brown precipitation, but they were not limited to not excess, so we can go with excess. So it is making this complex. The complex is more stable, so that silver plus concentration is decreasing. Now silver plus is existing inside the complex. So to increase that, to increase silver plus, first reaction, this is moving back to forward, so that acetate concentration is increasing. So that's again, solubility of silver acetate is increasing. So again, increasing, and increasing. Silver nitrate, addition of silver plus, to decrease that, this is going backward. So that's decreasing. If you go with everything, all common ticks are going on with this. 119, answer 3. Ask me, Ronnie. Question number 150. Two different series given. 5 into 10 power minus 4. 4.5 into 10 power minus 4. This is less. So KOH is a limited factor. So the remaining become the difference between these two. That is 5 minus 4.5. That is 0.5 into 10 power minus 4. 5 into 10 power minus 5. Total volume is 50 plus 10, 60. Divide that H plus concentration by 60. That is this. Then get the minus log 10. 120, answer 3. Sorry. Suji enna? $121. Which one of the following indicators could be used for the titration of this benzoic acid with this? Okay, weak acid, weak base. Should use conductometry or potentiometry. 121, answer 5. Question number 122 is true. True statements. pH of pure water can be less than 7. So this dissociation is endothermic. So that when temperature is increasing, this is forwarding more and more to right. Dissociation increases, more and more H plus and OH minus in the medium. So that pH is decreasing. KW is also increasing, that's possible. The pH of pure water can be greater than 7 when temperature is decreasing. Same phenomenon backward. Can be negative when pH is 10 m. H plus concentration is 10 m. pH can be negative. Cannot be greater than 14. That's again wrong. 10 power minus 15 means pH supposed to be 15. 122 AB correct. Answer 1. Question number 123. See, answer 4. To get that answer, you even don't want these calculations. 10 to the power minus 9 is less than 10 to the power minus 7. So 10 to the power minus 7 plus 10 to the power minus 9, almost 10 to the power minus 7. Minus log 10 H2 plus is pH, that's 7. See, water gives 10 to the power minus 7. But HCl, since concentration is 10 to the power minus 9, H plus also given 10 to the power minus 9. Understood? So 123, see they are doing such questions as well. Answer 4. When the given concentration is less than a concentration of pOH plus, you don't need calculations. So we have many questions you finished. Okay. Done a lot. Question number 124. The concentration of an aqueous solution of weak monobasic acid is 0.1 m. pH is 3, dissociation constant. pH equals to 3, minus log 10 H3 plus is 3. Then H3 plus concentration is 10 to the power minus 3. Then this HA, weak acid, I'm going to get as HA. And with water, it's reducing H3 plus to the medium. Since H3 plus is 10 to the power minus 3, this is 10 to the power minus 3. A minus is supposed to be also 10 to the power minus 3. Since you have initially 0.1, then at equilibrium, HA's concentration is supposed to be 0.1 minus 10 to the power minus 3. Here, even it's not that small, we have to consider this as 0.1 because 10 to the power minus 3 is a smaller. Go with the calculation, go with the substitution for this equation. So you can get the answer very easily. 124, answer 5. Oh, look what happened. Oh, okay. Yeah, push yourself. I want you guys to do this question ahead of me, okay? Up to which question you did, tell me? Okay. Easy questions you were doing. Question number 125. There are no indicators suitable for use in titration of no. If whatever this, even you don't have to read that part, if this is strong and they were not mentioning concentrations, this is weak acid, strong base, drastic pH is in between 7 to 10. So basic indicators, I've given 2 examples, phenolphthalein and cresol red. Potassium propionate undergoes hydrolysis in aqueous. Yeah. All salts dissociate completely this way. Hydrolysis, water involved, dissociation separate into ions. The connection between hydrolysis and dissociation. Anyway, 125, answer 4. Hundred 26. 25 milliliter of 0.04 m hydrochloric acid, 25 of 0.02 sulfuric. So 0.04 has same amount of H plus, and here 0.02 has twice of H plus. So finally same H plus, 1 into 10 to the power minus 3, 1 into 10 to the power minus 3. That is the total. pH is asking volume 25 plus 25 here, that's 50. Divide by 50, get the H plus concentration. Minus log 10, answer equals 4. 126, answer 4. And 27. Concerning acid-base indicators and simple titrations, true statements asking. Methyl orange can be used as in the titration cannot be. They say cannot. Cannot is wrong. Strong acid, strong base. First and second. Phenolphthalein cannot is again wrong. Methyl orange can be used to determine the amount of sodium carbonate present in the sodium carbonate, sodium bicarbonate. Phenolphthalein can be used to determine the amount of sodium carbonate. Yeah, if you use methyl orange, you get sodium carbonate plus sodium bicarbonate. But if you use phenolphthalein, it's going only to the partial neutralization of sodium carbonate, so that we can get only the concentration of sodium carbonate when you are using phenolphthalein. Are you okay here? Because phenolphthalein only gives this color difference only at this level. But with methyl orange, sodium carbonate goes to CO2 to give. Also, sodium bicarbonate goes to CO2. So both these are occurring with methyl orange. Only the first one is occurring with phenolphthalein. In the presence of phenolphthalein, endpoint of sodium carbonate to sodium bicarbonate can be found. Sodium carbonate can be calculated so that. Question number 127, answer 4. Okay, when you're going through the recording the second time, this little part I have added. I'm not going to read that. I don't want to waste timing. I'm going to keep more time during last couple of weeks to make you relax, not now. Question number 128. At a certain temperature, Kw water is given. pH of aqueous solution of acidic, the concentration 10 for minus 10, asking at that temperature. I'm going to get this water. This is 10 for minus 12 mean H plus OH minus concentration together is 10 for minus 12. Get the root value. So the either H plus OH minus 10 for minus 6. And then acetic is 10 for minus 10. Let's say alpha is dissociating per mole. Then for 10 for minus 10, H plus is 10 for minus 10 alpha. But here this is supposed to plus with this. So that the H2O plus totally equals 10 power minus 6 plus 10 power minus 10 alpha become 10 power minus 6 minus log 10. So you don't need calculations. pH equals to 6. Got it. Monobasic weak acid, Ka is this. POH is asking when the concentration is 1. If alpha is dissociating, 1 minus alpha, alpha and alpha. So Ka equals alpha multiply alpha divided by HA, alpha squared. So initially 1 is the concentration, so 1 minus alpha become 1. So that cross multiply alpha squared equals to this Ka value. So you can get alpha 10 to the power minus 3 minus log 10, 10 to the power minus 3 is 3. Alpha mean H plus concentration. Then POH equals 14 minus 3. That is 11. Okay, or otherwise from directly from KW you can get the answer as well. 129, answer 5. 130, a few drops of methyl orange indicator and magnesium powder. Added to ammonium nitrate. Ammonium nitrate supposed to give back ammonium hydroxide and nitric. Medium is acidic, you guys know that. Nitric with magnesium, magnesium nitrate and H2 gas. So this is reacting. Ammonium hydroxide remain in the medium, which is a weak base. Since basic, methyl orange gives its basic color. And also magnesium is a metal, so that does not react with bases. No reaction with cold water. React only with hot water and water steam. So no such reactions. So this is the only reaction possible. Methyl orange turns yellow. Yellow is the basic color. Hydrogen is liberating. That's again true. 130 BC correct answer too. This is not water vapor. This is supposed to be steam. Okay, this is steam. Inorganic. Just write in again to refresh you. Question number 131. A pH value varies. When acid is strong, it fully dissociates in aqueous medium. Therefore, same concentration of acids have same amount of H plus. Anyway, I'm going to go with the answer. Weak base, strong acid, acidic. So pH supposed to be less than 7. Cesium perchlorate, strong acid, strong base, 7. Sodium carbonate, sodium bicarbonate, you know that. This is more acidic, more basic, 11. Sodium bicarbonate, we did calculation for 0.1 m, that is 9-ish, 9.6. So that 131 answer 4. Question number 132. Which one of the following statements wrong with pure water? Value can be less than 7 or more than 7, that's possible. With the temperature increasement and decreasement, this is happening. So I'm just showing in the temperature is decreasing, dissociation is right. HOH increasing, pOH decreasing. H3O plus is greater than Kw. OH minus greater than Kw. Yeah, because H is 10 to the power minus 7. But Kw is 10 to the power minus 14. So the 10 to the power minus 7 is greater than 10 to the power minus 14. Pure water, H plus OH minus concentration is equal. 132, answer 5. 133, we did this for kinetics as well. Ethanol, C2H5OH, labeled oxygen 18, and unlabeled ethanoic acid, that's a carboxylic acid, with conc H2SO for the catalyst. True statement is asking, say, oxygen 18 is attacking as a nucleophile onto this carbonyl carbon here, but that's unstable. Oxygen has plus charge. So this hydrogen gets away, coming to this position, but this 2 OH unstable. So one is releasing as H2O, but both these conditions are exactly identical. So you can leave this H2O, this H2O from that, but still, even with those, oxygen 18 is already joining to this alcoholic oxygen, so it's not going to water, it's in the ester. The water formed as a product, no O18. The ester formed as a byproduct, so the product of this radioactive oxygen, these three, 16, 17, 18, naturally existing stable isotopes. Ester formed as a product has O18. Yeah, the ethanoic acid remaining unreacted does not have, yeah. No reaction means it is pure. So there is no 18 here. So question number 133, C, the correct answer. 3. Question number 134. Indicator is more suitable for the titration between barium hydroxide and propanoic. So weak acid, strong base. Transition pH is in between 7 to 10. So the best example is 8.3, cresol red. 134 answer 5. Memorize all these pH ranges. Because this 8.3 is supposed to match with or come in between 7 to 10. That's the best indicator. Question number 135. True statements asking, the value of an aqueous solution cannot be pH, cannot be negative. That's wrong. We did that under question 122 as well. When the pH value of an aqueous solution decreases by 2 units, the H2 plus concentration increases 100 times. Okay, decreasing 2 units, 10 to the power 6 to 10 to the power minus 8. This goes from 6 to 8. If you divide this is 100 times. 2 units mean 100 times. The pH value of pure water decreases with increasing in temperature. Dissociation is endothermic. pOH supposed to be also decreasing both. 135, BC correct answer. Question number 136. The concentration of an aqueous solution of sodium hydroxide is 10 to the power minus 4. pH is asking, sodium hydroxide totally give the same amount of OH minus. This doesn't matter. This is strong base. pOH equals 10, 8, sorry, 4. Then pH equals to 10. To happen this is happening only when the temperature is 25. Since it's not mentioned, did you guys get the answers too? Yeah, you're going to get marks. If they were not defining this one, but they were given this. 136 answer 5. So what is the answer? 2. Think clearly, really carefully. Get the style. That's why we are doing this. We have the full knowledge, but still a style yet to get. Style yet to get. Uh, 137. 1M aqueous solution of monoacid is dissociating 25%. Ka is asking. 25% means 0.25 and 0.25. So the remaining become 1 minus 0.25. This is not very, very small. So you can get the answer 0.275, 0.25, 0.25. Do the substitution. 137 answer 3. Ka value of ethanoic acid, ammonium hydroxide, Kb given. 4 cubic centimeter of 1 m solution of ammonia, 0.1 m ethanoic acid, whatever it is, just when they are going to equivalence point, that's fully neutralizing. Then pH is supposed to be around 7 because Ka, Kb almost equal. Ka almost equals to Kb, therefore almost same amount of H plus and OH minus reduced to the medium. Neutral at endpoint. 138 answer short. Enemy, do you want a break? 139. 50 cubic centimeter of sodium hydroxide, 100 cubic centimeter of acetic, 0.1, 0.1. pH equals to 4.75. So 50 is neutralizing with 50. But then this is a buffer solution. So sodium hydroxide is finishing. 50 cubic centimeter of acetic is remaining. Since this ratio is 1:1, 1:1, same amount of sodium acetate is making, let's say 50 cubic centimeter is converted to sodium acetate. So then this is a buffer solution. pH remains unchanged. Even if you add 1 cubic decimeter to this one, it's not changing the pH. 1 cubic centimeter, it's not changing the pH. 139 answer 5. What time is it? 10:53. I was waiting to get. Okay, 7 minutes break is enough, I guess. Yeah, I'll be back at because otherwise no time for your break because you guys class ends at no, yeah. Oh my goodness. You guys, how does the time is starting? No, at what time we started the class? 2. So at what time we finish the class? 5:41. Oh. Yeah, you have, yeah. Anyway, let's get to this break. We have 1 hour and, yeah, not half, 150. 1 hour and 50 more minutes. Anyway, I'll be back after some time. Get the break. Okay, let's start back. I have something to show you. Are you guys having crushes? Celebrity crushes, only that. And honestly, you guys, yesterday we went to this ICT, but that's something that, like, cycle and then until it gets here, let's continue the class. One of the students, she was District 13th of Ratnapura. Unbelievably awesome. She talks about her crush in the class. I asked her to come to give this talk to 26 students. Seriously? Oh yeah, it came. Why? And then Mali again Negala. Do you have such brother? He was no, he just all of a sudden he ran and he jumped onto her body. Very common. Yeah, another one is coming. Whoever asked him, I want to see you. Then I was like, just come this time and that time, and I'm just dividing them to classes. They are coming at class time, they are giving this, they are. No, it's not, you guys can't hear this. Manu, do you have a crush? Sorry, I know you guys are feeling a little embarrassing. Now she says, now she, I mean, now she says the crush is there. Then I said, now she's saying I had hormonal. That's how she started. Amma is outside in the class. Then she was like, yeah, it comes with age. When you're having hormones, you are having these crushes. Then I was like, then in Antoni, age එක පස්සේ crush එක ඉවරයි. නෑ ඒකලම් තාම ඉවර නැහැ. She says she has gone on this counseling. She was feeling that hard about that boy. Okay. No, she's really brave. Like she talks about that in front of everybody. Then she said, even her sister was here. Oh, now in the class. The class now. Yeah, it's up to you. Okay. We checked this Samsung S24 Ultra phone yesterday. Then they didn't have this orange color one. I wanted the orange color. And they said they would bring it today. Then they are like, they had a couple of phones yesterday. I think, you know, this in Harbor, they were just caught some of these unauthorized phones imported to Sri Lanka, something like that. I think they want to increase the price or something. So they said that now, yeah, now you can try it. We should wait until we go somewhere else. Okay, this girl is saying about the crush and everything. Then she's asking you all too, not to fall onto these girls or boys. This is natural. But if you think too much, then you cannot control yourself. Your age is that kind of a age. And when you are getting closer to exams, especially, you trying to was also laughing so badly. When I was asking about this class, then I was asking from the class who's having, say, hormonal issues. Then a couple of boys raised their hands. Maybe fun or I don't know what is it. Anyway, so if you have such condition, just forget until this little short 5 months is passing. Then you have more like mature brain, so you can think more logically and critically. Don't let this happen to you. And she says once she's done with the exam, when she was talking about this with her friends, she said almost all of them were having some sort of crushes. They were like not going to love us, but they were feeling like that someone is there. Then when she says That's like, that is called a crush, like for the celebrity crush. Celebrity crush is all right because you know that's never going to happen. With who you're having that crush? Yuck! Come on. Not like multiple crushes at the same time. Okay, right now, who is that? What? Oh, that's Korean. Yeah. Korean boys are almost look like girls. Seriously, Buddha, I have you watched those? I did because everybody is like, some are being very crazy. They were pass with their exams nicely, but I think they can do better if they are not watching those. Then they are named Madam Mohammed Kiana, Madam Tute Balwarang, like even from their phones, they're showing me. Okay, question number 140. Don't fall for them, okay? This is your life. They are not coming to give you results. They are not coming to give you money. Oh, luxury life. They are spending their life. The color change of pH intervals of 4 acid-base indicators PQRS are shown here. Ammonia and perchloric. Ammonia is weak base. This is a strong acid. So drastic pH supposed to go in between 3 to 7. Okay, 3 to 7. This is away. This is above 7, so that's basic. But all these three we can inclusive to 3 to 7. See, so PQR are suitable. 140 answer 4. Are you going to run the through today? Okay. Okay, question number 141. Which one of the following relationships concerning pH of aqueous solution of 0. C the same concentration, all are same concentration? Are true. If you go with all 4, this is a pH is around 11, pH is around 9. Then this is almost acidic. This is acid. Sorry, this is basic. This is basic. Strong as BaCl. Sorry. This is coming through this barium hydroxide and perchloric. Strong acid, strong base. That's around 7. Then this one, this is the base part. Acid is H2SO4. So this is the lowest, which has the acidic nature. So they were given 2 conditions that you can get from this one. Question number 141, A, B, correct answer 1. KB given, the relationship of KB and KW asking here. Ka releasing, because ammonia given, so first I'm writing Kb for that, releasing OH minus to the medium, or taking up H plus is the basicity. Releasing of H plus is acidity. So let's write Kb, Ka separately, multiply these two. Kw equals Ka into Kb. 142, answer 5. (143) at constant temperature, pH of aqueous solution changed from 8 to 6, 8 to 6, 10 to the power minus 8 to 10 to the power minus 6, that is 100 times. The change has occurred because H plus increased 100 folds. 8 to 6 mean acidic, increasing. So that's why it's increasing. 143, answer 3. 144. Methyl red is a suitable indicator for the titration between ammonia and H2SO4. Strong acid, weak, base, acidic indicator. You should remember these pH ranges 4.2 to 6.3, so that's possible. 3 to 7. Methyl red indicator is yellow in alkaline medium. This 6.3 yellow. While it is red, 4.2 red in acidic medium. Not reason is this colors, but the reason is this in this titration pH is falling onto pH range of the indicator. They were not saying anything to give that hint. 144, answer 2. (145). Even if the pH of an aqueous solution is less than 7, it could be neutral. Yeah. H2O dissociation is endothermic. Temperature increasing, HOH greater, pH, POH less. So even less than 7, it can be neutral. Under certain conditions, the value of Kw could be higher than this. Yeah. Higher, when you increase temperature, dissociation is increasing. H plus OH is increasing, so that Kw is increasing. 20, 10 power minus 6, 30, 10 power minus 12 is greater. This is greater. That is the reason, even because this is always balancing with the temperature. This is increasing and decreasing, so that pH is increasing or decreasing accordingly. 145, answer 1. (146). 999 pure distilled water was adding to 1 cubic decimeter of HCl. Now 1000. Then to that solution, you are taking 1 cubic centimeter out of that. This is the second dilution. Then again, you are adding another 999. So that's a double dilution. Initial solution get diluted 1000 folds. Only taking 1 cubic centimeter of that. H plus concentration should be very lower. Then initially 0.001. Then first become or dilute into 1000. Then during the second dilution, it's become another 1000. 10 to the power minus 9. pH of water becomes slightly higher than 7. It's above 7. That is the logical part. Or otherwise, initially 0.001, 1 cubic centimeter, 1 into 10 to the power minus 6. That again dilute into 1000. To convert this into 10 to the power minus 2 cubic decimeter, 10 to the power minus 3. This is the volume. So this is the concentration. That again diluting to another using another 1 cubic decimeter. Second dilution. So, okay. This is the new concentration. You're going to get another 1 cubic centimeter. So this is the number of moles. Again, dividing by 1000, this same 1 cubic decimeter. So this is the after second dilution. But water has 10 to the power minus 7. So 10 to the power minus 9 plus 10 to the power minus 7 is 10 to the power minus 7. Get the minus log 10, pH equals to 7. Clear this. Logically, you can get the answer, or using calculation, you can show this. A student performed several titrations separately between several 25 cubic centimeter portions of certain aqueous solution of KOH and 0.1 mHBr. HCl, HBr, HI all are strong acids. Only HX is weaker. The HBr solution was in the burette. KOH solution was several days old. That you guys know, CO2 dissolves in pure water and decreases pH. But pure water is neutral. Still, it can dissolve CO2. KOH is more basic. So, CO2 dissolution in KOH is more effective. When KOH gets old, CO2 dissolve in it. CO2 plus KOH makes potassium carbonate and potassium bicarbonate. Potassium bicarbonate is unstable, get away easily. So that all KOH only has KOH plus K2CO3. Memorize this knowledge. In one titration, he uses methyl orange. Second titration, phenolphthalein. Burette readings are different because with phenolphthalein, KOH neutralization, K2CO3 partial neutralization occurs. But with methyl orange, including those two, this third reaction is also possible. So that the volume difference is supposed to be the volume that taken for complete neutralization of potassium bicarbonate to CO2 and H2O. Clear that? The difference has arisen because K2CO3 in the KOH solution. Question number 147, answer 3. Anything to ask? 148 question. Which of the following aqueous solutions will have the highest pH value? Highest OH minus concentration. This is acidic, let's say around 5, because HCl. This is again acidic, let's say only pure acetate. But 0.001, never get closer to this. Let's say if this is 0.1, that this can be between 5 to 6, okay. 0.01 means 10 power minus 2. So pH equals to then POH equals to 2, pH equals to 12. This is ammonium hydroxide cannot be that high. Let's say that's 10, but this is strong base, calcium hydroxide, 0.006, but you have 2 OH, that is 0.012. That's greater than 12. 12 means 0.01. 148, answer 5. A solution was prepared by mixing 100 cubic centimeter of 0.1 m ammonium hydroxide and 0.1 m ammonium chloride. 0.1 m ammonium chloride. This is a buffer solution of weak base and it's sort of strong acid. Then addition of further 10 cubic centimeter gets diluted when addition of water. Henderson equation, salt divided by base. But then salt and base, both concentrations are equal. So it's not affecting pH or POH. Decreases concentration of the solution, keeping the pH. Yeah, pH is constant, but since diluting, concentration can be changed. Question number 149, answer 4. Question number 150. Always pure water, drastic pH. This, okay, let's say this is 3 to 11. So this is the pH of pure water, which equals to 7. See, even if you add a little amount of base, this is going below 3. Sorry, acid. If you add a little amount of base, this is going above 11. So when you are adding something to pure water, that shows the highest difference. Anyway, we're going to do the calculation. I've done with this table here. Initially HCl, so the same pH, final pH. Sodium hydroxide, 1 mean, let's say 0, but I'm going to go as 14. 13, adding 1 cubic centimeter doesn't do much difference. 1 can be neutralizing. Water is just 7. I'm going to come to calculation with that. Buffer solution, the fourth one is buffer solution. Weak acid, it's sort of strong base. This is also some sort of a possibilities here as well. But if you go with water, initially it's 7. To that you're adding 0.1 in 1 cubic centimeter, 1 in 10 to the minus 3. Total volume become 24 plus 1 is 25. Then concentration become 4 into 10 to the minus 3. pH become 2.3979 starting from 7. So this is the largest difference. Clear? 150, answer 3. Then you add 0.1 mHCl. HCl, no difference. Here, let's say 1 is neutralizing, but still almost same. Finish. Question number 151. Suji, ara amba ටික එහෙම දැම්මද? පොළොවලොත්ලා? In the titration of 25 cubic centimeter portion of sodium hydroxide solution with HCl, 25.0 cubic centimeter, they are just saying to one single decimeter. But if you measure something exactly to the titration flask, we are using the pipette for that. So this is supposed to be then sodium hydroxide. This is supposed to be sodium hydroxide. Then with HCl mean HCl is supposed to come to burette. Is that clear? Burette. Washing pipette with HCl. No, burette with HCl. Titration flask with sodium hydroxide increases number of moles of sodium hydroxide. We don't do that. A temperature is not necessary, and otherwise it is temperature sensitive something. A 0 mark is not necessary. We can get the difference. Let's say 30 already done. Then let's say the next reading is 40. 40 minus 30 is the reading. Rinse the inside the burette with HCl. Yeah, this is the burette. Question number 151, answer 5. (152). 1 mole of acidic is added to 1 cubic decimeter of pure water. Following true statements, pH become less than 7, almost maybe 3, 1 moles per cubic decimeter, so that concentration of H plus ion in the solution is now greater than OH minus because now we externally added H plus. Concentration of H plus ions in the solution is approximately no. If this is strong, 1 moles per cubic decimeter with 1 mole divided by 1 cubic decimeter, 1 moles per cubic decimeter is the acetic acid concentration. But since the dissociation is weaker, H plus is very, very less. C incorrect. Does not completely dissociation. That's why C incorrect. B correct. The 5. Question number 153. An aqueous solution of ammonium chloride is weakly acidic. Yeah. Ammonium chloride undergoes partial ionization in the aqueous. Wrong. This is a salt. All salts dissociate completely in aqueous medium. And why this is acidic? Knowing this chloride, we know this is supposed to come from strong acid HCl, so we say it's acidic. But 2 questions that you cannot say with anything, that anybody, that's wrong. That's only for your own understanding. But to explain, this is releasing, this weak base is releasing conjugate acid. Conjugate acid releases HCl plus. So it's acidic. But since the dissociation is weak, so the acidity is also less. 153, answer 3. Hundred 154. The value of pH of 1 in 10 minus 3 most nitric in water approximately. Either you can get almost 7 or little less than 7. Nitric 10 power minus 8, but water is greater than 1, 10 power minus 7. If you add 1 in 10 power minus 7 plus 1 in 10 power minus 8, I'm going to convert this 1 into 10 power minus 8 to 0.1 into 10 power minus 7. Since these two are 10 power minus 7, I can add up these two. 1 plus 0.1 is 1.1 into 10 power minus 7. Get the minus log, that is 6.9. So either it's 7 or 6.96. 2 answers, 3 and 4. Is it confusing? Moving on. 155. Given below are the pH ranges of color change intervals of 5 indicators. Most suitable to titrate 1 into sodium hydroxide and HCl. But when concentration is 1 into 10 power minus 3. So now the pH, drastic pH range become very, very narrowed. It's between 6 and 8. So the most suitable one is closer to that 7, in between 7. Strong acid, strong base, but concentration is 1 into 10 power minus 3. So drastic pH lies between 6 to 8. 155, answer 3. 156. A solution S was prepared by complete dissociation of pure calcium chloride and pure calcium hydroxide in water. Concentration of each solution in S is 0.005. What's the pH of the solution? Okay. Calcium chloride is a group 2 chloride. Completely water soluble and a strong electrolyte which dissociate fully in aqueous medium, inorganic knowledge. Calcium hydroxide, partially soluble, strong electrolyte. Normally, calcium 2 plus acts as a common ion for calcium hydroxide solubility. But in this question, they say calcium hydroxide fully dissolved in the solution S. Therefore, remember, common ion effect does not affect here. Calcium hydroxide came through strong acid, strong base, so it doesn't affect the pH of the medium. So only this is acting separately to give OH minus to the medium. 0.005, 1:2. So multiply by 2, 0.01 is the OH minus concentration. Get the minus log 10, that is 2. So that pH equals, this is POH, okay? So that pH equals 12. It's supposed to be POH. So that question number 156, answer 5. Question number 157. A solution P contain 0.5 m ammonium hydroxide, 0.1 m ammonium chloride, pH is 10. To this, we are adding 1 cubic centimeter mole amount of 0.1 m sodium hydroxide. A mixture of weak base and its sort of strong acid, a buffer solution, so that pH remain constant. 157, answer 3. Titration rules. In an acid-base titration, the acid should always be, no, generally, but not always. There are no such rules. This is supposed to be in this container, burette or pipette or titration flask. The burette should always be filled up to 0, not necessary. The solution remaining at the pipette tip after delivering a blown, no, it's just you are holding the tip. Whatever the dripping down is enough. That is the 25 cubic centimeter. Some titrations do not require an indicator to be added to detect the midpoint. Yeah, if they have self-indicators. For the calculation, the average of the two burette reading at the endpoint should be taken if they are close, not widely different to each other. If widely different, we omit the deviated one. 158, answer 4. 159. Which of the following compounds, when dissolved in pure distilled water from solution, which is turned red litmus blue? Basic. Weak acid, strong base, basic. This is again weak acid, strong base, basic. Strong acid, strong base, neutral. Lithium nitrate, strong acid, strong base, neutral. Only A, B correct. 159, answer 1. Question number 160. Methyl orange pH range is 3.1 to 4.4. Gives the correct endpoint for the titration of 1 into 10 power minus 3. Concentration is really lower, even the strong acid, strong base. So that pH, drastic pH cannot fall into this gap. So it is falling in between 6 to 8. So this is away from 6. So you cannot use it. If the drastic pH range is in between 3 to 11, this is possible. So the first statement is wrong. For the titration of this is 0.1 and 0.1. Usually any indicator can be used. Yeah, usually any possible. 160, answer 4. Question number 161. This actually is an alternative method, but this is accepting to the exam. For the exam, they are expecting that normal finding this n equals to CV method, but this method is also applicable. Okay, mole ratio, sodium hydroxide to sodium carbonate is 1:2. Sodium hydroxide X, sodium carbonate 2X. 25 cubic centimeter of this solution titrating with 0.1 mHCl. Phenolphthalein 15. They are asking the methyl orange. Okay. Sodium hydroxide, either phenolphthalein or methyl orange, just going the same way. Sodium carbonate with phenolphthalein going through this partial dissociation. So that these two equations for phenolphthalein, and that is 15. But with methyl orange, this sodium bicarbonate, same sodium bicarbonate, is again complete neutralization to CO2 and H2O. And then this is 15. Ratio is X is to X and 2X is to 2X. So that it is making exactly same amount of 2X. That 2X is here. See, X plus 2X, 3X is proportional to 15. Then how much supposed to be? This. So 3X equals 15, X is 5. Then altogether for methyl orange, you would have X plus, 2X plus 2X here. Altogether, it's supposed to be 25. Clear that. Did you do this for theory? I guess yes. Yeah. Anyway, so hydrolysis, aluminum chloride, inorganic chemistry, it gives aluminum hydroxide and 3HCl. HCl just dissociate to water to give H3O plus and Cl minus. PCl3 again shows the hydrolysis reaction, H3PO3 and HCl. Magnesium chloride, just comparing to other inorganic, this is weaker, but still magnesium and chloride we can consider neutral. pH is almost 7. Ammonium chloride, ammonium hydroxide, and HCl. Okay, then 3HCl and 1H3PO4. This is the most acidic. So this is has the lowest pH. Then this is again releasing exactly same amount of H plus. So next one is this. If you compare this one and this one, so this is amphoteric, so less basic than more basic ammonium hydroxide. So when it is joining with ammonium hydroxide, it's more basic, so pH is greater. But this is almost neutral. So the greatest pH goes to magnesium chloride. They were not asking this increasing order. We did for your practice. Anyway, for this question, 162, answer 4. Give me a second then. Okay, one has sent because I was doing Ratnaka class, English medium class on Wednesday morning, but now they are sending this school started, so I have to shift it to tomorrow. So I just announced that. That's frustrating. I had to leave tonight or tomorrow morning to do the tomorrow evening class. Anyway, question number 162, answer 4. 163, the pH of 0.01 moles per cubic decimeter solution of sulfuric is lower than that of 0.01 mHCl. Sort of yes. Let's say even the dissociation is not twice, but still this has only same amount of H plus. This is having even a little amount of higher H plus, mean it is getting or pH is lower. In dilute aqueous solutions, H2SO4 is stronger than HCl. No, this is from inorganic knowledge. HCl is more stronger than H2SO4. Even you have 4 oxygen, but sulfur is less electronegative. That's the reason. 163, answer 3. Question number 164. 25.00y. That's you are measuring with the pipette, putting onto titration flask. This is y, so that this is y. Then the burette supposed to have x. Then most accurate one, first burette washing with distilled water, then by X solution, titration flask only you are washing with distilled water. Others are wrong. 163, 64, answer 5. 165. With phenolphthalein, endpoint is 25 cubic centimeter. This sodium carbonate mixture, same HCl, same sodium carbonate. When you're changing these two, HCl and sodium carbonate, now they're asking what is the burette reading. Okay, see. HCl and sodium carbonate. So we are adding the phenolphthalein here. So initial color of the mixture is pink. And if you change these two, even if you have phenolphthalein added here, acidic color of phenolphthalein is colorless. Then sodium carbonate to HCl, colorless, 1:1 ratio. Since same CV, 25 and 25, same concentration. Sorry, same volume, same concentration. Okay, that is they are saying it's 25, same volume. Okay. Then when we are having this HCl here, adding sodium carbonate here, until the solution become basic, they are not showing the pink color. Then how does the medium become basic? Okay, sodium carbonate HCl gives sodium bicarbonate and sodium chloride. That sodium bicarbonate with HCl gives sodium chloride CO2H2O. Then the stoichiometric ratio is 1:2. This is the equivalence point, but still color is not pink. Then we're going to add little excess of sodium carbonate to the medium to see the color. At that time, the reaction is not halfway, it's totally completed. So that if you have 25 cubic centimeter of HCl, since the ratio is 2:1, then sodium carbonate is supposed to be 12.5. Understood? 12.5, let's say we can plus 1 drop or so on. None of all these are like crystal clear, very clear. So they are stopping here burette solutions. So that question number 165, answer 2. Answer 2. 166, same sort of a question. This time, sodium hydroxide has 10 to the power minus 9. And here 10 to the power minus 6, they are saying this is 10 to the power minus 12 at 80 degrees Celsius. So that at 80 kW equals 10 to the power minus 12, which is H plus and OH minus multiplicity. So that OH minus concentration will become 10 to the power minus 6. So the total equals 10 to the power minus 9 plus 10 to the power minus 6, these two together. Almost equals 10 to the power minus 6, since 10 to the power minus 9 is very small. 166, answer 2. We had 1, 2, 3, 4, 5. This is a sixth question. 123, 28, 36, 46, and 50. For all are same sort of questions. $167. At 25 degrees Celsius, the OH minus concentration of an aqueous HCl solution with pH equals to 5 is 10 power minus 9. Okay, Kw equals 10 power minus 14, which equals H3 plus and OH minus. Then if OH minus concentration is 10 power minus 9, then H plus concentration is 10 to the power 5. Or directly, pH is 5, then H plus concentration is 10 power minus 5. OH minus concentration decreases to 10 power minus 10 when the solution is diluted tenfold with distilled water. When diluted by 10 folds, H plus concentration is also decreasing by 10 folds. So that pH is increasing by 1 unit. So that new pH is supposed to be equals to 6. So that new H plus concentration equals 10 power minus 6. And also H plus concentration coming from water is also equals to 10 power minus 7. Okay. It's not decreasing if you calculate the concentration, okay? Then H plus concentration become 10 power minus 6 plus 10 power minus 7. If you add these two together, 10 power minus 6 I can get as 0.1 into 10 power minus 6, 10 power minus 7, okay? So add these two together, you can get 1.1 into 10 power minus 6. Kw is 10 power minus 14. Knowing H plus concentration here, you can calculate OH minus, which is 9.1 into 10 power minus 9. It's not 10, so that's wrong. Second statement. The concentration of OH minus ion in the aqueous solution always decreases when diluted with distilled water. Sodium hydroxide is decreasing, but this is neutral. So you cannot decrease the concentration by adding water. Clear that? Okay. Also pH is constant. Because when you're adding water, you're adding same amount of OH minus to the water as well. So sort of it's increasing. Okay, second statement is wrong. 167 answer 5. Mm. 49. Okay, question number 168. Do you feel these questions are harder or really challenging? For now, I feel like these questions don't have that much challenges. For now, let's go on. I guess all questions are same. A primary standard is a solid of whatever they are giving, and primary standards for acids, bases, and redox are fixed in theory. You have to memorize that. That's theory. 168, answer 4. $169, I lost the annotation. When a finely ground mixture of copper metal and metal X is placed in a HCl, pH is increasing. So with HCl, they are making something to make this, or decreasing or reacting with HCl. To make the solution basic mean, HCl is reducing, so something is reacting with HCl. And you know, copper doesn't react with HCl. When the same mixture is placed in sodium hydroxide, pH decreases mean it is reacting with sodium hydroxide. That's why pH is decreasing. Elements below hydrogen in the electrochemical series do not release H2 gas with Gill acids, reacts with conc oxidizing acids. So that this element cannot be copper. So then X supposed to have something which is reacting both with acids and bases. The annotation. As an example, this can be zinc, which is amphoteric. 169, answer 3. A weak monobasic acid HA has a dissociation constant this. The solution B, C, and D are prepared by mixing separately 10 cubic centimeter solutions of P 0.02 m aqueous solution of HA. Okay, so they were made solution B, C, and D with these three at 25 degrees Celsius, decreasing order of concentration of A minus. First one, solution P. And then පොඩි වෙලා නේ එළියදලා මම UFO folder අපි ඩුබායි වලින් ගමු මොකද ඔච්චර වද වෙන්නේ no I'm just saying let's just suspend it why we are not in a hurry. They said yesterday they had the phone, then today they said it's sold out. Like they were, yeah, when the phones are a little expensive, they are getting pictures to post on this FB and Instagram. You don't have to talk like secretly. Feeling embarrassing makes your voice more and more like talk secretly. I guess so. I'm not even an I guess something I want to tell. Really? Enemy? I am keep charging your batteries. Why feel like only it's harder? It's like impossible. Hey Royal, hey Anna, hey Nana, and everything. Happy fight number. Hey Ratnapura, I have a couple of bullets in Ratnapura. Trust me. In these schools, it's harder because they are making some questions like impossible to understand. Tute, last year, how many students were selected to biology and engineering, maths? 50? 50? No. Hmm? No. Supposed to be less than that. Usually. This year? 59? Oh, really? Hello? I got a meeting. Oh. Ah. Ada hari. Oh. Ada. Hari. Hari මට රික්වෙස්ට් එකක් දාන්න මේ ලින්ක් එක වල. ලින්ක් එක වල රික්වෙස්ට් එකක් දාන්න මම දැන් ක්ලාස් එකේ ඉන්නේ. කමක් නැහැ. දාලා තියෙන ඉතින් මට මතක් වෙනවනේ. හරි. ඕකේ. මොකකට හරි. I thought before chemistry. අන්තිලා 25 English 26 English medium class එක හෙඩට වැටුණා. ඒගොල්ලන් ස්කූල් යනවා දැන් Wednesday morning. ඔව් මේ වීක් එකේ ඉඳලා Tuesday අපිට වැඩේ. හෙට ඉඳලා. හරි. 2:20 5:30 හෙට විතරක්. ඊට පස්සේ 6 ගන්න. 2යි. ඔව් දැන් ක්ලාස් එකයි. හරි පස් කතා කරමු. දාන්නකෝ. හරි. මොනවාද? බයෝ. එනයි ඉන්නවද? කාටවත් නැද්ද? my final exam, no, 2019 they had. 2019. Yeah. I guess, yeah, because they were given parking symbols really losing because they had so much issues. Final exam එකේ දෙනවා අඩුද? Yeah. Even this girl got 50 out of 60. Make your own guessings. Maybe again, I'm meeting bio special. Okay, shall we continue? Little more time, 25 minutes. All right. Solution P, same. First one is 10 cubic centimeter of water, 0.004 HCl, 0.004 sodium hydroxide. Okay, this is HA, this is HA dissociation. 10 cubic centimeter water dissociation increases by dilution, but A minus concentration is decreasing. Number of moles increasing, but dividing by volume concentration is decreasing. Addition of H plus shifts this reaction to backward, left. So A minus is decreasing, but this is water. So more and more decreasing with addition of acids. So C is supposed to be less than. Removal of H plus by sodium hydroxide, moving this reaction to forward. So A minus is increased. So the C supposed D supposed to be the greatest. B C, then D supposed to come to this side. So this is the answer. 170, answer 3. $171. Consider a sample of pure liquid water, neutral, where the ionic product of Kw is this. Dissociation of water is endothermic. Temperature increases, dissociation increases, H plus OH increases, Kw increases, Kw high, and each H plus OH minus become 10 to the power minus 6. So that pH equals to 6. The sample is neutral. OH minus concentration equals to H plus concentration. Not mean wrong. OH minus is also 10 to the power minus 6. A, D correct. 171, answer 4. Question number 172. Correct steps. Titration rules. Level of solution in the pipette is adjusted to coincide with the graduation mark. The tip of the pipette must be held immersed. They are asking that we have to dip this tip inside this solution. That's not possible. We are not doing that. We are doing such thing only in the Winkler method. This is the titration flask. We are inserting this pipette inside to avoid, if you are percolating this like this, if you are just adding solution from here, it is adding even a little bit of O2, mixing O2. To avoid that, we are dipping this inside. That's only with Winkler method. In transferring the solution to the titration flask, the pipette tip should be held against the inner, you are just touching the wall of the container or the titration flask. In transferring the solution to the titration flask, the pipette should be held vertical. Pipette vertical, this is inclined. True. The little bit of solution remaining in the lawn, again, they're asking, no, we're not doing anything, I'm just holding it like 10 seconds, then just leave it. Let's say this is the burette. This is the burette. You have a little drop remaining here once you introduce all the solution. But the red part exactly is 25.0 without that blue point. Okay. So 172 BC correct answer. Sorry, any question? Question number 173. Which of the following will show the largest change of pH when 1 cubic centimeter of 1 m sodium hydroxide solution is added? So that's again this one. Okay. 20. Okay, all these concentrations are 1. Okay. So 1. Okay. ධෝනි රත්නපුරද කලම්බුද? ඔයා රත්නපුරද කලම්බුද? සිංහලද ඉංග්‍රීසිද? ක්ලාස් එක තියෙන්නේ සිකුරාදා හවස මට WhatsApp එකක් දාන්න මම ඔයාලට ඉන්ෆර්මේෂන් ලියන්නම්. ඔයාව ක්ලාස් එකට ගන්න මට ඔයාගේ සයන්ස් මැත්ස් මාක්ස් දැනගන්නත් ඕනි. ලාස්ට් ටර්ම් ටෙස්ට් එකේ සයන්ස් වලයි මැත්ස් වලයි ලකුණුත් එක්ක ඔයාගේ ස්කූල් එකයි ඔය විස්තර ටික මට WhatsApp එකක් දාන්න. Okay. I don't know whether they are lying because I'm not taking their reports. They can do what? They can write whatever they want. Okay, see. 1 cubic decimeter of acetic, 1 cubic decimeter of acetic is neutralizing with 1 cubic centimeter of sodium hydroxide. 19 cubic centimeter is remaining. So 19 cubic centimeter this. So if you want, you can calculate. The difference becomes 0.1. Initially 1, finally 0.9. So the difference is 0.1. 1m to this 20, you are adding another 1, so concentration is not changing. Third one is a buffer solution, not changing. H2SO4, 1 cubic centimeter of sodium hydroxide, same as this. So 1 cubic centimeter is neutralizing, 19 cubic centimeter is remaining, so the difference is very less, same as this. Okay, this one, 1 into 1 into 10 to the minus 3, this is the number of moles. Total volume become this 20 plus this 1 cubic centimeter of water. Sorry, sodium hydroxide, 21. Divide by 21, get this concentration. Get the minus log 10 of that, that is a POH. Then 14 minus that value become pH. pH difference is initially 7, now it is 12.6, difference is 5.6. That's the largest. 173 answer 5. Question number 174. pH, whatever the order, so they were given increasing orders. A is ammonium chloride acidic, let's say 5. B, ammonium hydroxide, directly only ammonium hydroxide, so pH is supposed to be a little greater, let's say 11. Then C is a buffer solution. If you have only ammonium hydroxide, it's around 11. Now, since it's having this ammonium chloride as well, then pH supposed to be less than 9. Okay, less than 9. So let's say this is around, sorry, less than 11, less than 11. Let's say this is around 9. Those are all 4. Then this is around 5, around, this is a neutral. This one, ammonium. This one is neutral. Sorry. Ammonium acetate, where is it? How come I have written ammonium acetate here? D. Ammonium hydroxide and acetic. Yeah, this is making the ammonium acetate. D is neutral. So D is almost 7, and this is acidic. This is a little basic. Ammonium hydroxide is more basic. 174, answer 3. $175. That polyprotic acids, I have written these numbers. If you feel these questions are confusing, continue to do such questions together. S is a solution of sodium carbonate and sodium bicarbonate in water. By which method that we can find the sodium carbonate and sodium bicarbonate? If you use phenolphthalein, only you can get sodium carbonate. This partial neutralization, by that you can find only sodium carbonate. Sodium bicarbonate, no answer. First methyl orange, then further with phenolphthalein. First methyl orange mean both are fully neutralizing. So even if we add phenolphthalein, it can't do anything. First phenolphthalein, then sodium carbonate is converted to sodium bicarbonate, but sodium bicarbonate is just existing as it is. Then C and D are same. In C, they are using one single solution. In D, they are using same 2 different solutions. Still the same results. Question number 175. C, D correct. Answer 3. Uh, 176 we did at the class. At that time, it was really confusing to you all, but I guess you guys are really okay now. Solution S is prepared by mixing equal volume of 0.2 m aqueous H2SO4 and 0.2 m aqueous acidic. So you have this mixture. Then you get 25 portions of S. Titrate separately with 0.1 m sodium hydroxide. One using phenolphthalein, another one using methyl orange. They are asking endpoint volumes. Okay. Strong acid, strong base. That is this connection. Drastic pH range is 3 to 11, so that both methyl orange and phenolphthalein answers. But weak acid strong base, and that is this connection. This connection, weak acid strong base. So only you can get answer with phenolphthalein. Methyl orange is away from this 7 to 11. Clear that? Manu, is that clear? It's supposed to be clear for girls because they were with me when we were doing theory. Okay. So when both acid and base are strong, methyl orange phenolphthalein can be used. For weak acid strong base, only phenolphthalein. Then we have to find how much is for phenolphthalein. That is only for acetic. Then how much is for methyl orange? That is together for acetic and H2SO4. Okay, then only for H2SO4. This is a CV, 1:2 ratio, twice of sodium hydroxide. That divided by the, this is the number of moles, divided by volume, concentration. So V equals N over C. Divided by concentration gives the volume. So this is, even if you use phenolphthalein or methyl orange, this is the volume of sodium hydroxide for H2SO4. Okay. Okay, then to this one, 1:1 ratio, same number of moles, that number of moles divided by concentration is volume. So that is 25, only in the presence of phenolphthalein for acetic. Okay, for phenolphthalein, both are acting, acetic and H2SO4, that's 75. Both these two occur, but methyl orange only H2SO4. Only this is happening for methyl orange. So that's one. So question number 176, answer 3. Moving on. (177). Solution A and D are prepared as A to D as follows. Correct order of pH. 10 cubic centimeter of ammonium hydroxide, 10 cubic centimeter of water, equal volume mixing, so diluting twice. So the new concentration is supposed to be half of this, that is 0.05. Ammonium hydroxide, ammonium chloride, equal volumes, this is exactly same. Ammonium hydroxide is always same. So I'm going to compare this, the other part. Then the concentration for B, this again supposed to be 0.15. So 0.15 divided by 2 is the new concentration because the half dilution, twice dilution. So 0.075, 0.075. Let's say the ammonium hydroxide is C, 1 minus alpha. C, now this becomes C alpha plus 0.075. This is 0.075. Okay. And this is CV. But still you have the common ion effect here. NH4 plus concentration, NH4 plus is a common ion. So this reaction to moving to left to decrease OH minus concentration. Then C condition. ammonium sulfate. But ammonium sulfate condition is little worsening because this time you have twice of, if you divide the concentration, that is 0.05 to get the half double dilution. But this is 1:2 ratio. This is ammonia concentration. Common, and if you're coming from 2 ammonia, so this moving more to backward. So the concentration of C is less comparing to concentration of B. Then D, 0.05 m aqueous ammonium hydroxide. Different concentrations. OH minus also is different. Okay, so 1 into 10 into 10 to the minus 3 plus 0.05 into 10 into 10 to the minus 3. Altogether now volume is here 10 and here 10, it's 20. Multiply by 10 to the power minus 3 to convert this into cubic decimeter. So that new concentration becomes 0.075. So that here, C is supposed to be smaller comparing to B and D together. And since 2 OH minus are adding here, this is supposed to be the greatest. Clear that? So D is the highest. Then C is the smallest. A is 0.05. So this is the answer. Question number 177. Answer 3. This is 0.075, okay? Okay, can I move on? Enough? Enough? It's okay, we can stop there. I guess you guys are a little tired now just writing. Let's start from there and let's start from here next day. We did up to question number 177. How many questions we finished? More than 100, I guess. No, less than, little almost 100, 80 something, yeah. Okay, bye, take care everybody. I mean, I'm gonna send you the Ratnapura recording to you, okay? Just hang in. Once we finish equilibrium, your chemistry life is going to be really easy. We did up to 177.